this is about as complicated as it gets. So one acetylene, triple bonded. Goes on to make two CO2s and one, so we're going to have to get this double to make it 5. So let's just do that in our head. 5 O2s, 2 ethylene groups, acetylene groups. It's got 2 different kinds of names to it. Double that is going to be 4 CO2s plus 2 H2Os. All we have to do is make sure whatever we got on one side, we got on the other. So when you're balancing these equations, the first thing you do is you start with the carbons. Count the carbons on both sides first. So 2 acetylenes, YN, means triple bond. 2 times 2 is 4. We look on this side, we got 4 CO2s, 4 times 1C is 4. Next we do the oxygen. No oxygens here. Here we've got 5 O2s is a total of 10. Here we got 4 CO2s is 8. 2 and the O's in the water is 10. So that works so far. Lastly, H's. We got 2 times 2 is going to be 4. No H's in there. 2 times H2, O2. It works. So this little formula here is pretty cool. If you could learn the algebra of doing this, you got 2 parts here. The first top part is going to give the bottom reaction part, the reacted product part. Erase that, get it out of the way. This is all there is to doing equations. You got X and Y's. This really could not be simpler. I mean, even though I'm doing this pretty scatterbrained, it worked itself out. The only thing I needed to know to do was, when you had the half there, was to double everything. And the more you do this stuff, kids, the more you get practiced at it. So just, if there's anything, it's like exercise, really, because the more you exercise, the better shape you get in. The more you do these equations, the better you get at it. It's undeniable. Some things you can study and study and study and you never get. Algebra isn't that way. You'll do it, you'll do it, you'll do it, and pretty soon you don't even realize it, but you're good at it. So this is what's called algebra. There's no calculus involved, there's no higher mathematics involved or anything. And as you see, it's just simply counting. So these are called your combustion reactions. And whatever on one side has to balance to be on the other side. So what happens is, if you have something like methane here, you see that one methane is going to need 2 oxygen molecules, 2 O2s, to get a complete combustion reaction out of this. Well, what if you only have 1? Okay, you got a carbon, you got 2 of these to go around. Well, water is going to be a product. Otherwise, it's not going to react. So look what you end up with here. A CO. This is what happens when incomplete combustion, they call it. Write it on there. Incomplete combustion. Incomplete combustion is going to give a carbon monoxide. Here's our triangle. Triple bonded O. Boing, boing, boing. Carbon monoxide. Not good for you. And this is what happens in your body when you're burning sugar. I mean, this is sugar. This is wood. This is oil. What do you get from it? You get the energy, you get the water. It's as fundamental, as simple a chemistry as there is in the world. And the first first time you see it, it may seem complicated, but really, it's simple, basic stuff. It doesn't get any simpler than this. Now, in this arrow here, actually, what happens is you're going to get radicals. And these radicals are what cause, they happen in your body. Just breaking up glucose causes these superoxide radicals, hydrogen peroxides, these peroxides, radicals. C with an O, unpaired electrons. You've got, before the water forms, you've got OH radicals. And that's why when these intermediate stages here, this is where when you got your N2 in there, before the carbons and hydrogens and oxygens get to bond and N2 gets in the way, before you know it, now all of a sudden you've got the NOs going. Put some unpaired electron in there. There's a radical. So this happens in a combustion chamber in your car. It happens in your cells in your body. It happens in your mitochondria when you're breaking down sugar. So there's a lot of applications to this. And once you learn it, then you start seeing where it repeats itself and comes up again in nature. Tell you what, let's play with the molecules some more here. Nitrogens, sulfurs. A good one that we didn't talk too much about is we've got CO2 in the air. And what the carbon does when it goes into water, it will form. It was an N carbon, wasn't it? Oh, water with the H's. Carbonic acid. C. Really how it looks when it's going on with this. Grabbing the oxygen, see them again, low budget here. We don't have the Velcros like those high price joints. So you got carbon with an oxygen and another oxygen. What are we looking at here? CO3. Just wrap that around there a couple times, hope it holds. 1H. 2H. And what this has is diprotic. See, there's 2 protons on this thing. So what's neat is CO2 in water. CO2, the gas, you breathe it in, you do it in your cells, all of a sudden your cells are expelling CO2, it runs into water. Carbonic acid is what this makes. So even when you're drinking pure water, the CO2 in the atmosphere is forcing a little bit of that in. It's making carbonic acid here. So what's the beauty of this? The pH of your blood needs to be at a certain temperature, certain pH. So say you got an excess of acids coming, well, carbonate can take a proton or it can give one up. So it keeps everything in equilibrium. So let's show what this looks like growing as